cooking device older than written language, built from dirt, under $2. It outperforms an open campfire by 4 to 6 times in thermal efficiency. Aprovecho Research Center measured it, 52% thermal efficiency with an optimized design. That is not a guess. That is a laboratory result. Now here is what should bother you. Go to ready.gov right now. Pull up FEMA's official disaster cooking guidance. You will find charcoal grills. You will find camp stoves. You will find zero mention of rocket stoves, zero mention of cob ovens. A technology used by every major civilization for 10,000 years does not appear on the page. Americans spend $8.5 billion a year on outdoor cooking equipment, grills, smokers, propane accessories, and all of it becomes useless the moment the propane supply chain breaks. Meanwhile, 4 bricks stacked in your driveway, burning twigs from the yard, can boil water faster than most camp stoves for $0. By the end of this video, you will know how to build both a rocket stove and a cob oven from materials in your backyard. You will understand the engineering principles that make them work, and you will know exactly which regulations stand between you and the oldest cooking technology on Earth. To understand how we got here, you need to understand how long this technology has actually existed. Welcome to the channel. What we do here is simple. We recover practical knowledge that institutions have either forgotten or chosen not to share. We do not sell products. We do not push brands. We dig into what works, what has always worked, and why nobody with a marketing budget wants you to know about it. If that sounds like something worth preserving, subscribe. You are joining a knowledge recovery community, not a fan club. Let's start where this technology started. 10,000 years ago, Jericho, 8000 BCE, the Jordan Valley. Archaeologists have uncovered the earliest known earthen ovens at this site, simple domed structures made of clay and mud. People were baking bread in shaped earth before they had written language, before the wheel, before bronze. Move east, Sumeria. The word is Tenuru. That is the Sumerian term for a cylindrical clay oven. Follow that word across 5,000 years. It becomes tanner in Arabic. It becomes tandoor in Hindi and Urdu. One word, one technology. Traveling across languages and continents for 10 millennia. Still in use today in restaurants on every continent. That etymology chain is not speculation. It is documented linguistics. Indus Valley, 3000 BCE. The tandoor reaches 900 degrees Fahrenheit interior temperature. Civilizations are cooking naan and roasting meat in earthen cylinders while Europe is still in the Stone Age. This is not primitive. This is engineered. Across the ocean, Taos Pueblo, New Mexico. Built between 1000 and 1450 AD, adobe construction, still occupied today. The oldest continuously inhabited community in North America uses earthen building and cooking technology that has not fundamentally changed in 1,000 years because it works. Medieval Europe. Cob ovens mounted on wagons followed armies. Communal village ovens served entire towns from Hungary to Quebec. In England, cob construction thrived from the 13th century through 1800. Thousands of cob buildings still stand. Some are still lived in. Now consider the engineering precursors. The Roman hypocaust system channeled hot combustion gases through floor cavities, directed airflow, controlled heat distribution. In 1780, the argon lamp introduced a cylindrical wick with a central air draft that dramatically improved combustion efficiency. The same principle. Channel air into the combustion zone, burn fuel more completely. Every one of these civilizations arrived at the same conclusion independently. Shape earth around fire. Control the airflow. Store the heat in mass. It is not a trend. It is thermodynamics discovered and rediscovered across 10,000 years of human history. So if billions of people use this for millennia, and billions still use it today, what does modern science say about why it actually works? Before we get into the engineering, I want to mention the vault. What we are covering today is one system. The vault contains dozens. Water purification, food preservation, off-grid shelter construction, medical preparedness with no pharmacy. Every topic gets this level of research. No filler, no fluff, no recycled internet lists. The link is in the description if you want the full library. But right now, stay here, because the science behind this technology is going to change how you think about fire itself. 1980. A man named Larry Winiarski formally develops the rocket stove at Aprovecho Research Center in Oregon. He does not invent the principle. He documents it, he optimizes it, he measures it. Here is the baseline. A 3-stone fire. 3 rocks, a pot on top. Open flame underneath. That is how roughly 3 billion people on Earth still cook today. Its thermal efficiency is 10 to 15%. 85 to 90% of the heat energy in that wood goes into the sky. Wasted. Now take a rocket stove with a properly fitted pot skirt. Aprovecho measured 52% thermal efficiency. That is a 4 to 6-fold improvement over an open fire using the same fuel. The difference is engineering. The shape matters. A J-shaped combustion chamber draws air in from below the fuel. The vertical chimney section accelerates that airflow upward. The fuel burns at the tips where it meets incoming oxygen. This is not a campfire. This is directed combustion. Here is the part that changes everything. Secondary combustion. When wood burns in an open fire, it releases volatile gases. Smoke. That smoke is not waste. It is unburned fuel. In a rocket stove, interior temperatures reach 1,000 to 1,800 degrees Fahrenheit. At those temperatures, the volatile gases ignite. The smoke itself burns. That is where the roaring sound comes from. The stove is burning its own exhaust. Advanced designs achieve 85 to 95% combustion efficiency. Field studies in India documented 39 to 47% fuel savings compared to traditional cooking methods. In 2012, the Himalayan Rocket Stove Project launched in Nepal. Over 60,000 stoves installed and functioning, measured reductions of 45 to 55% in carbon monoxide emissions, 40 to 84% reduction in indoor air pollution. The World Health Organization has documented that indoor smoke concentrations from traditional cooking fires reach 10 to 100 times recommended levels. Rocket stoves cut that dramatically. Aprovecho won the Ashton Award in 2006 for their work. Oregon State University's Extension Service explicitly recommends rocket stoves for Cascadia earthquake preparedness. This is not fringe science. This is peer-reviewed, award-winning, university-endorsed engineering. Now the cob oven, different principle, same material, same brilliance. You build a dome of clay, sand, and straw. You build a fire inside it. The thermal mass of those walls absorbs radiant heat. When the fire burns down, you rake out the coals. The walls release stored heat for hours. Think of it as a battery. You charge it with fire. It discharges as cooking heat. Bread first at 350 to 450 degrees Fahrenheit, then roasting, then slow cooking as the temperature gradually declines over hours. One firing. Multiple meals. No fuel consumed after the initial burn. A technology this effective, this proven, this cheap. You would expect it to be on every emergency preparedness checklist in America. It is not. And the reasons why tell you everything. The U.S. outdoor cooking industry generates $8.5 billion annually across 38,890 businesses. The outdoor kitchen appliance market alone is $7.2 billion. Globally, the outdoor kitchen market exceeds $26 billion. Weber, Traeger, Camp Chef, Coleman, Napoleon. These companies sell products that require recurring fuel purchases. Propane canisters, $3 to $5 each, charcoal bags, replacement parts, upgraded models. A rocket stove runs on sticks from the ground. There is no consumable input to sell. There is no replacement part to manufacture. There is no upgraded model to release next quarter. Clay, sand, straw, bricks, and fire are unpatentable. Aprovecho published their designs as open source. You cannot build a business model around something that costs $0 and requires no supply chain. Now look at the regulatory landscape. International Fire Code Section 308.1.4, 10-foot setback for open flame devices. Fairfax County, Virginia, 15-foot setback. Phoenix, Arizona prohibited residential fireplaces entirely in 1998. California Fire Code Section 308.1.4, South Coast Air Quality Management District, no burn days. Here is the absurdity. You can buy a propane grill at Home Depot and set it up on your deck this afternoon. No permit, no inspection, no regulatory review. Propane grills are a documented cause of apartment and deck fires nationwide. Nobody stops you. Try building a mound of clay in your backyard and see what happens. A cob oven, depending on your jurisdiction, can trigger a building permit requirement, a fire department inspection, a zoning review, potential denial. For a dome of mud and straw that has no gas line, no pressurized fuel, no moving parts, and no documented history of structural fire spread. In 2019, the International Residential Code approved Appendix U, which provides a formal pathway for outdoor cooking appliances, including masonry ovens. But adoption is voluntary. Your local jurisdiction may not have adopted it. Many have not. I want to be clear. I'm not telling you this is a coordinated conspiracy. I'm telling you the incentive structure is perfectly aligned. An $8.5 billion industry has every reason to promote products that generate recurring revenue. Regulatory bodies default to commercial, standardized, inspectable solutions. FEMA recommends what manufacturers produce and retailers stock. A technology that costs nothing, requires no brand, and cannot be sold, does not have a lobby. It does not have a marketing budget. It does not appear in the guidance. The omission may not be malicious, but it is consistent. And it is expensive for anyone who finds themselves without power, without propane, and without options after the next major disaster. Ask the people in Puerto Rico after Hurricane Maria in 2017. When the grid went down, survival cooking happened with found materials, not with products from a catalog. If you have made it this far, You are exactly the kind of person this channel exists for. This is the kind of information that does not have a marketing budget. No corporation profits when you learn to cook with dirt and sticks. If you think more people should know this, subscribe. Share this video with someone who thinks they need a $500 grill to feed their family. The vault link is in the description for the full research library. Stay here, because now I'm going to tell you what you need to know before you stack your first brick. I'm going to be straight with you about limitations, because if I only told you the upside, I would be no better than the people selling you propane. Fire hazard is real. Non-combustible surfaces matter. Those setback distances in the fire code exist for legitimate reasons. Do not build a rocket stove on a wooden deck. Do not build a cob oven against a fence. Use concrete, gravel, or bare earth. Carbon monoxide. Wood combustion produces it. Period. Outdoor use only, every time, no exceptions. No enclosed spaces, no garages, no tents. Brick explosion. Moisture-saturated bricks under extreme heat can crack violently. Use fire brick or dry standard brick. Never use bricks pulled from a wet pile after rain without drying them thoroughly first. Efficiency caveat. That 90% combustion efficiency figure applies to optimized rocket mass heaters, not to 4 bricks stacked in your driveway. Aprovecho's own researchers found that without a pot skirt, a rocket stove is, and I quote their finding directly, only about as efficient as a well-run open fire. The pot skirt matters. The insulated combustion chamber matters. The design details are what separate a novelty from a tool. Cooking limitations. A basic rocket stove produces intense, concentrated heat. Excellent for boiling, excellent for frying, poor for delicate simmering without practice and modification. Use cast iron cookware. Thin aluminum pans can warp under the concentrated heat. A cob oven requires 4 to 7 days of drying time before first use. It needs weather protection. Rain degrades exposed cob. A simple roof overhang or tarp extends lifespan from a few years to 10 to 20 years with basic maintenance. Legal risk. An unpermitted permanent structure in your backyard can result in fines and a removal order depending on your jurisdiction. Know your local codes before you build anything permanent. A 4-brick rocket stove is temporary and portable. A cob oven is a structure. Now that you know the real picture, here's exactly how to build both. 4-brick rocket stove. Materials. 4 standard bricks, ideally fire brick, but any dry brick works. A metal grate, cooling rack, or piece of expanded metal for the top. Thumb diameter dry sticks. Tinder, a lighter. Total cost, $0 to $10. Build time, under 5 minutes. Step 1. Place 2 bricks parallel on a flat, non-combustible surface. Leave a gap between them roughly 3 to 4 inches wide. This is your fuel feed channel. Step 2. Place a 3rd brick across the back end of the gap, closing the rear. You now have a U-shaped channel open at the front. Step 3. Stack additional bricks upward on both sides of the rear portion, building a vertical chimney 3 to 5 layers high. Stagger them slightly for stability. Step 4. Place your metal grate across the top of the chimney opening. This is your cooking surface. Step 5. Insert thumb diameter dry sticks into the front opening of the feed channel. Push them halfway in. Do not pack them. Air needs to flow beneath and around them. Step 6. Or slight tinder at the base of the sticks where they meet the vertical chimney section. The chimney draft will pull the flame upward. Step 7. Feed sticks gradually as the tips burn. Push them further in as they are consumed. You control heat output by how many sticks you feed and how fast. You will hear it before you see the full effect. A low roar as the draft accelerates and secondary combustion engages. That sound means it is working. A pot of water will reach a rolling boil in 7 to 10 minutes. Basic cob oven. Materials. Clay-rich subsoil from your property or a local source. Sand, straw, fire brick for the baking floor. Standard rubble or urbanite for the foundation. Wet newspaper, a bucket of water. Total cost, $0 to $50, depending on whether you source materials locally or purchase fire brick. Our build time, 1 to 2 active days plus 4 to 7 days drying. Step 1. Build a foundation of stacked rubble, concrete block, or urbanite to waist height. This gets the oven opening to a comfortable working level and keeps moisture away from the base. Step 2. Lay a flat bed of sand, roughly 2 inches deep on top of the foundation. Place fire bricks tightly together on the sand bed. This is your baking floor. Level it carefully. Every gap or wobble shows up in your bread. Step 3. Build a dome of damp sand on the fire brick floor in the shape you want your oven interior. Typical interior dimensions are roughly 20 to 24 inches across and 12 to 16 inches high at the center. Cover the sand dome with a layer of wet newspaper. This is your release layer. Step 4. Mix fire cob. 2 parts sand to 1 part clay. No straw in this layer. Add water gradually until it holds shape when squeezed but is not dripping. Pack this mixture over the newspaper-covered sand dome in an even layer, roughly 3 inches thick. Smooth it. Let it set overnight. Step 5. Mix insulation cob. 2 parts sand to 1 part clay to 1 part chopped straw. Same moisture level. Apply this as a second layer roughly 3 inches thick over the fire cob. Smooth the exterior. Step 6. Let the entire structure dry for 4 to 7 days. Do not rush this. Cracking from premature heating is the most common failure. Step 7. Once dry, reach through the oven opening and scoop out all the sand from the interior. The newspaper layer lets it release cleanly. You now have a hollow clay dome. Step 8. Temper the oven with a series of small fires over 2 to 3 days. Start with a handful of kindling. Gradually increase fire size each session. This drives remaining moisture from the walls without thermal shock. Step 9. For your first full firing, build a fire inside and maintain it for 1 to 2 hours. Let it burn down. Rake the coals to one side or remove them. The interior walls are now radiating stored heat. Slide bread in on a wooden peel, close the opening with a door or wet towel. Bake at 350 to 450 degrees Fahrenheit for 30 to 45 minutes depending on loaf size. One firing gives you bread, then roasting temperatures as the oven cools, then slow cooking heat for stews or beans for hours afterward, no additional fuel. Step back from what you have just learned and consider what it means. 10,000 years. Jericho to Sumeria to the Indus Valley to Taos Pueblo to medieval Europe to Aprovecho Research Center to your backyard. One continuous line of human engineering. A technology older than writing, cheaper than a pack of gum, more thermally efficient than anything in the outdoor cooking aisle at Home Depot. And it has been regulated into obscurity while being excluded from the emergency guidance you would need most. The person who can build a rocket stove from 4 found bricks and a cob oven from backyard soil possesses a skill that cannot be confiscated. It requires no supply chain. It functions after any disaster. It costs nothing to maintain. No manufacturer can discontinue it. No retailer can run out of stock. No power grid failure can disable it. That knowledge is now yours, permanently. Send this to someone who thinks cooking requires electricity. Send it to someone who thinks emergency preparedness means buying more products. The Vault link is in the description for the full research library, including water purification, food preservation, and off-grid construction guides at this level of detail. This is what we do here. We recover what was known, we validate it with modern science, and we make sure it does not disappear behind a paywall or a permit office. 4 bricks, 5 minutes, boiling water. That is where it starts.